now. Okay, so hello. I wanted to start first with what the Gaucho space looks like. I did some updating. Billy also did as well. We are combining forces, so everything is in one space for this class. We hope that that kind of simplifies matters. At the top, you can see lecture information. I will also be adding midterm study guides and the prompts for any other information about the midterms and finals up here as well. Section information. Billy RTA knows so much more about using Gaucho Space than I do, even though I have been here like a few years longer than he has. So he's been able to add a picture. You can see his lovely visage right there. Section syllabus information, a link to scheduling for his office hours, and the section Zoom links. This is especially important today as 2 out of 3 of the sections are today. Let's see, moving on. For this week's stuff, I updated things where we have a label for every single day, and you can see what the readings or videos are and to prepare for today or prepare for each day. Then a link to the lecture on YouTube. I am keeping them on YouTube for now because I know that it is easier to caption them that way. I am still working out how to do that. That is after lectures task for me today as well. I think I figured it out for one, but not all of them. So thank you for your patience on that, especially if you are watching these asynchronously. So scrolling down, down. At the bottom of this week and at the bottom for weeks in the future, you will see the prompt for the response paper. So each week you will reflect and respond to a set of questions regarding that week's readings. Your response should be 1.5 to 2 pages or about 500 words, and it will be submitted here on Gaucho Space. Technically right here. So consider sources we have read for the week in lecture. While a works cited page or proper MLA, APA, Chicago, any of those different formattings, citations aren't needed. Successful responses will consider multiple sources from class material and lecture. So what does that mean? You could say in lecture 2, Nikki, or however you want to address me. I usually prefer Nikki, but Nikki discussed this. Or in Fable for Tomorrow, Rachel Carson's example shows this about blank. Successful responses will do that. How you do that is really up to you. The biggest thing, the most successful ones will be using sources to further their argument. So further the answer to the question, each of these questions, both of these questions that are, wanting you to dig in a little deeper, to take the material, to use that to make your own sort of argument and support it with the material. So the 2 questions I have for you are these. So skeptics often claim that we shouldn't worry about current climate changes because our planet has experienced climatic cycles in the past. Do you think that this true statement about past climate cycles is a reason not to be concerned? Explain. And then tomorrow we're going to start talking about the Anthropocene today, but we're going to be talking about it tomorrow as well. So the Anthropocene is the period during which humans have become a dominant force, spoiler alert, shaping our planet's environments. So given this week's preparatory materials, so all of these things that we have looked at, do you think the Anthropocene is the best term for what we're doing? Why or why not? So if not, then what would be better? And so this last question in particular is really coming from today and tomorrow's lectures, where today we are talking about the 6th mass extinction of life on Earth, which means that we are going to do probably the deepest, biggest dive into history, to the point that this is just a very condensed, abbreviated chronicle of just different processes, that different forces that have happened since the Big Bang, which sounds scary. Me just saying that sentence makes me a little nervous. This is it is hard. It turns out it is very hard to try to condense the history of the world in less than an hour, but we're gonna try. And because that helps us get to where we need to be, which is the sixth mass extinction of life on Earth, also called the Holocene extinction. But it also helps us understand the Anthropocene. And these two things are contributing to climate change, or global climate change, and they're also contributing to many of the other environmental justice or just environmental issues that we will be talking about for the rest of the course. So this is very important. And even though you don't need to know the ins and outs of the Hadean eon or the Pleistocene, there are going to be a couple of these on your midterm study guide. Don't worry, I will give you all of those terms. Probably by the end of this week, you'll be able to find it at the tippy top, right? Oh, even the tippier right here. So for material that will be really useful for the midterm and the final, and if you are doing the other extra credit option, that will be found there as well. You can find it right here. So I know that while I was talking, I saw the chat light up. I'm assuming that at least some of it is you answering each other's questions, because you all are very good at that. But I am going to just double check. Okay. Somebody tried to eat Camilla's face. That is cool, I think. Labels are very helpful. Yes, I am glad you think so, Madeline. I was very excited to figure out how to do that and have them stand out more. Look at me. 1.5 to 2 pages double space. Yes, I am not I'm not a sadist. I am not here to make your life especially hard. However, if you write more, Billy, if somebody ends up writing a novel, I will grade it. That is fine. Billy is doing most of the grading for this class. So if you feel like writing a whole bunch, just know that I will probably grade it, not Billy. Madeline asks, can we use a first person or should we use third person tense in our responses? That is a great question. I would prefer third. However, if you have personal connections to something that you're talking about, or if especially as we go on and we are talking about specific case studies, maybe you grew up around one of these case studies. When we talk about Flint, Michigan, maybe you know people in Flint, Michigan. Those are the kind of places where you can make those personal connections and use first person. Third person is preferable because for the most part, you will not know the people, places, or things that we are talking about. But when you are being directly impacted by these people or places or things that you're asked to write about, you can use it. I ask you to not use second person because even though Billy and I care about you a whole bunch, and you will likely get to know both of us as the quarter progresses, you likely, so you is an example of second person, so you likely do not know enough about us to use second person, because second person is presuming a lot of information and an informality about the reader, who will be Billy and I. So I hope that makes sense. I hope that answers the question. And I'm glad that there are connections going for our new student, Owen, who is just joining our class today. So this is great. Okay, if there are any other questions, you all have been so helpful and friendly with each other. I'm glad to see that going. And Billy is also super informative and really great at answering questions as I go as well. So if a question doesn't get answered by the time we're done, I'll answer them at the end. So I will stop sharing and look at the beautiful gallery of people as I move to the share screen again. And I move to our PowerPoint for today. Play from start. So here we are. here we are. I'm pleased just by random things. Like, they're just little things, especially on the internet, that make me happy. And when I saw that this was a suggested slide, when I typed in what is the sixth mass extinction on the slide, it made me very happy that PowerPoint knows enough about the environmental crises that we're in to suggest a polar bear, one of the most emblematic species of fauna that we have to represent the climate crisis that we are in today. So many nonprofit environmental organizations have used the polar bear and the shrinking ice caps and the oceans rising to explain our environmental plights today. And I don't know, I just also think it's really cool that it's animated. So here we are. Here we are, and we are moving much like that polar bear. So, like I said, we're going to try to do the history of the world in less than an hour. This still frightens me, but we're going to do it anyway because it's important to know, in the broad sense, where we've come from so we can understand where we are. So on the left, you can see pretty famous picture. This is us. So at that dot that the arrow is pointing to, that's home. That's us. This was really famous picture from the 1970s. Billy will actually tell you more. And Billy, do you want to correct me right now? Do you want to unmute? Not to put you on the spot, but you know more about space history than I do.
What did you? I didn't catch exactly what you're saying. I was responding to a chat.
I'm sorry. Do you know anything about? Do you remember the specifics about this picture that was taken? The looking back to take a picture of Earth from far, far away.
No, I probably should remember more of the details.
All right. It was Sagan, though, right?
Yeah, it's Sagan. He talks about it. He has the pale blue dot quote. I can't remember if it was Voyager or not that took the picture.
Okay, it was Voyager. Thank you. Yeah. Besides being awesome, you're so knowledgeable. Thank you. I have so many friends who do space history. I do not do space history. I do tree history. But yes, this is the pale blue dot made famous by Carl Sagan's quote about it, and it was a picture taken on Voyager. Initially, it was not going to be taken at all, but Carl Sagan advocated for the photography equipment to also snap a picture looking back at where home is, because Carl Sagan felt, and other science popularizers at the time thought, that it would help for space exploration advocacy. Sorry again, Billy, to put you on the spot, but you are a joy and a delight, and you knew stuff even though I put you on the spot. So, history of the world in less than an hour. So our universe, 13.8 billion, that is billion with a B, years old. And most physicists believe that it began with a Big Bang. So does CBS. Oh, no, the Big Bang Theory is not on TV anymore, just in syndication. Anyway, so everything starts with a Big Bang. And this is related to the second law of thermodynamics, which states that total entropy or disorder will always increase in a closed system. So this is a physical system that doesn't exchange any matter with its surroundings. And if you reverse the second law and run it back in time, you end with the most orderly possible configuration, a singularity or a point of infinite density and gravity. We're working with disorder, though. We're working with entropy. We're working with PowerPoint that doesn't want me to advance to the next slide. So the Big Bang timeline looks mostly like this. We start with pure energy, and then we have a quark soup. Fun fact for any of my literary friends, the word quark actually comes from James Joyce's Finnegan's Wake. It is it's a word that doesn't necessarily mean anything, but it seemed descriptive enough to talk about the quirkiness of all of the particles in this area, or from that time. Then we move on and on to the creative force of chaos and entropy, creating atoms, then creating something like skies and galaxies and stars and the sun, and who knows what will go on. But since the Big Bang, the instant something was created from nothing, the history of the universe has been a story of increasing entropy. And again, entropy is chaos, confusion, completely complex, bungled, confusing. It's a mess. So the Big Bang then created the fundamental forces, properties, constants, and laws of the universe as we and science knows today. So we have space, time, matter, motion, mass, energy, dimension, electromagnetism, gravity, nuclear forces, just to name a few. If you don't recognize John C. Reilly, this was from a really fun bit, I want to say 15 years ago on the internet. If anybody's interested, I can find a link. It is very funny. He is encapsulating the astronomers who just know too much and don't know necessarily how to communicate it with the public, like the opposite of Neil deGrasse Tyson. Anywho, fun internet things. But this is all to say that disorder and chaos are really creative forces, contrary to maybe what family and friends told you when you were a child with a messy room. Disorder and chaos are creative. They're life-giving forces, which is not to say that you shouldn't clean your room, by the way. But from a smooth, superheated post-Big Bang plasma, our universe evolved to form quarks, like I mentioned, but also atoms, nebula, stars, and planets. You have warm areas of dense matter and energy that's separated by vast, mostly empty, at least to what our eyes can process, expanses. So let's get into it with our sun. So our sun is considered a yellow dwarf star. And it was formed around 4.6 billion years ago, and now accounts for more than 99% of the mass of our solar system. It produces nuclear energy in its core by fusing hydrogen to make helium, and this reaction supplies most of Earth's energies. So, even though not everything is solar, in the sense where we have panels everywhere that we have figured solar energy, we have not figured out how to make it completely sustainable, et cetera, things we will get to, I believe, in week 4. We are still very much solar creatures on this solar planet that really needs the sun, and without it, we would die. Yeah, we desperately need this yellow dwarf. Earth, of course, is a rocky planet as opposed to a gassy one like Jupiter. Jupiter is a gas giant. That's its actual classification. So Earth formed around 4.6 billion years ago by gravity from a protoplanetary disk of rocky debris orbiting around the sun, which we just talked about. It is in what's called the habitable zone, a comfortable distance from its parent star to support life as humans understand it. So Earth is really fragile, as we have talked about, and we will continue to talk about as we get into ecosystems, as we get into the effects of climate change, as we get into the processes, which we will get to very soon. There is little leeway in like the big scope of things, little leeway for life on Earth to exist how it is now. So even though it emerged from chaos, it is still pretty remarkable and kind of beautiful in a sense to think that you know, all of the explosions, all of the constant breaking up of material and creation of new material and atoms and clouds and planets, etc., came to a point where I am now talking to you through like through the internet, coming to you live from a suburb of LA with you probably can't see my screen, but like with like a little Ewok stuffed animal next to me. I don't know. The beauty of the processes that we're talking about astound me, even though I don't quite understand them because I haven't dedicated my whole life to these things. It is important to at least understand the bigger story, and there are going to be points, especially in this lecture, that I do not know the most about, but I'm more than happy to learn about them with you or to point you in the direction of more people who do. I am just kind of framing the rest of the things that we are talking about today in a pretty broad sense, just so we can have an understanding of how we got to where we are now. But this is my caveat for the rest of things, because there are parts of this lecture where, you know, I am not an expert in it, but I am an expert in learning and an expert in learning with you. So that is my caveat. So let's get into it, because we're going to be talking about eons and more eons. So Earth has gone through 4 major phases, and these are known as eons, over its 4.6 billion year history. Again, that is billion with a B. Let's get into it. So this one's my favorite one, the Hadean Eon. It's my favorite because I like Greek mythology, but this is the Hellish Eon. And this was about 4.5 to 4 billion years ago. So you're going to be seeing BYA and MYA. And if you don't know, that stands for billion years ago or million years ago. So Hadean is 4.5 to 4 billion years ago, a period which was devoid of life with constant volcanic activity. During this time, the moon and the first oceans likely formed, and we can see the movement of water and moon and the core kind of, for lack of a better word, figuring itself out and forming the base of geology happening. We have magnetism starting to rile up, and we're still getting bombardment from objects from space, which are, like we talked about yesterday, also shaping our geology, also shaping the land as well, as we now know it today, even though it was so long ago. The next one after that is the Archean Eon, and this was about 4 to 2.5 billion years ago, and this is where we first see life. It was only single-celled prokaryotes, and there's this theory, I just needed to include it, called the slime ball Earth, where Earth during this period had an atmosphere of volcanic and greenhouse gases. I like the term slime ball, but I also think that given the combination of volcanic gases and greenhouse gases, that does really sound slimy. So from this, we see, we see the water that was created in the Hadean become oceans. We see even more geology forming through tectonic activity. We have the first continent form. So truly we have geology now. We also have life. We have these single-celled prokaryotes. We have iron being formed and the beginning of oxygen. The next eon is the Proterozoic eon, and this was about 2.5 billion to 541 million years ago. So now we're in the million years ago. And we have an oxygen crisis after getting oxygen. We have some issues with balancing gases. Prokaryotes start to give way also to eukaryotes. Instead of a slime ball Earth, we have a snowball Earth with multiple ice events. Because we have eukaryotes, this is multicellular life. And I'm sorry that this image is so so unclear, but we also have ozone stabilizing at the end of it. So this eon starts with an oxygen crisis, and through, all of those years, going to 541 million years ago, we have the ozone begin to stabilize. Finally, I love this picture. It looks like a poster I would definitely have in my room as a child. Part of the reason why I included it. Sorry again that this also looks much more blurry than it did when I made this PowerPoint. I'm sorry, but we end with the Phonerozoic eon. So this is our fourth eon, which goes from 544 million years ago to the present. And I spelled began as began, much like it sounds like it has a British inflection. Sorry. Began with the Cambrian explosion. So that was 540 to 520 million years ago. And with that came a complex of new plants, animals, and fungi. Look at all of these cute babes, except you kind of can't because it is unclear. Yeah, this is the explosion of life. This is the Cambrian explosion. And we have all sorts of funky, fantastical animals coming forth and eventually developing to and evolving to where we are now. So with the Phanerozoic eon, we had the Cambrian period, like I said, where diversity exploded within our eon. We've had 5 mass extinction events, and then we will get to the 6th one after. So we have 5. The 5 before started here with the late Ordovician. I've heard people say it a handful of times. Ordovician, where 85% of all species, including marine invertebrates, went extinct. Then the late Devonian, which was where 75% of species died. The third, which was the largest, was the Permian, and that was where 95% of species passed and went extinct. The fourth, Jurassic, my favorite because of not only Jurassic Park, but also this is the period when redwoods came about. Don't mind me fangirling my favorite tree. But then the 5th mass extinction, which was only 145 million years ago, 76% of all species went extinct, including our non-avian dinosaur friends, some bivalves, ceremonids. That didn't come out of my mouth correctly, I'm sorry. But also flying reptiles. So 5 mass extinctions. But Nikki, you had us watch something about the 6th mass extinction. What is that? We'll get to that. I want to talk about the Permian's Great Dying, because it was the worst one. It was the Great Dying, like we saw on the last slide. This was where 95% of the world species went extinct, and this was, of course, in the Permian period, and this was about 292 million years ago. So 95 species in total, but 96% of marine species and around 83% of all genera. So genera is the genus part of genus species, if you know anything, or if you've experienced or spent time with taxonomic names. I also wanted to highlight this because I also liked this picture. The shark is very dramatic. Yeah, I just wanted to take a moment to appreciate the shark. But yes, so this was the worst one, the worst death, the worst extinction, and this was the 3rd mass extinction. So after the 5th mass extinction, we also have an event occur called the Paleocene-Eocene, which is the thermal maximum. So by 55 million years ago, after that the fifth mass extinction, life was starting to rebound. We had mammals beginning to diversify and proliferate. We have new groups like bats and primates emerging in the hothouse climate of the Paleocene-Eocene thermal maximum. So things are heating up, literally. So this was a time period where the global average temperature rose about 5 to 8 degrees Celsius, and during the cusp of the Paleocene and Eocene epochs. So this led to a massive carbon release, making things warmer. So with the warmth and also a steadiness of that warmth, we were able to see, or not we, but mammals were able to begin to get comfortable enough to branch out and move, and then with that evolve and change, and with that keep going and proliferate. But beginning around 2.5 million years ago, the Pleistocene epoch featured a series of at least 11 major ice ages and interglacial periods. This complicated things. We don't have any pictures of ice ages, of course, but we do have we do have some art from the 2002 classic movie Ice Age. If you haven't seen it, it is okay, but also available on Hulu. I do not know if it is good anymore, but I did enjoy it like 20 years ago. So we have different ice ages happening that are impacting the world, impacting the flora and fauna on it. And these repeated ice ages were due to patterns of the Earth's orbit around the sun. Again, we are a solar-powered planet. And these were known as Milankovitch cycles, which combined with the positions of the continents enabled the growth of glacier and ice sheets. So you can see a graph here. I'm unsure how else to try to explain it, because it is just the Earth twirling and then also twirling, and the eccentricities right here making the issues of the Earth being very cold and making an ice age happen. If you want things more specific, I am more than happy to learn with you, but that is how a very kind environmental science graduate student explained it to me 3 years ago. So that happens with the ice ages. We also have people. The ice ages helped with people movement as well. We'll get into that in a little bit. But we have to note that the anatomically modern humans appeared sometime around 300,000 years ago, and one of the several closely related primate species also went extinct. We also almost went extinct several times. So there was nothing inevitable about humans ever happening, nor our bodies being in the way that they are. It was really, really by chance, especially with all of that ice. So Homo sapiens emerged from Africa at least 70,000 years ago, reaching Southeast Asia by 50,000 years ago, Australia and Europe around 40,000 years ago, and the Americas 15,000 years ago. If you want to be more specific than that, we have indigenous folks reaching what is now considered the western coast, or the western section of the North American continent by 11 to 13,000 years ago, settling in California 9,000 years ago, specifically in Santa Barbara with the Chumash 9,000 years ago, just if you were curious. There are multiple theories about how folks moved. The most steadily agreed upon is that people traveled across the Bering Strait in a landmass that is now underwater, that we have now called Beringia, and people were able to pass across, I believe it was 1,000 miles, and it was 12 miles across, and they were able to eventually make all of the distances that they did. So yeah, like I said, there are different theories. I say theories because that is what they are. Science is commensurable. Science is something that is the best readily available knowledge that the scientific community has worked together and come up with. However, things like more information can be found and change some of these theories, but I will say that it is unlikely that these theories would ever be completely debunked, but more or less tweaked. That's kind of if you are in the sciences at all. I have a lot of respect for you anyway, just because you're a person, but people who pursue science are really part of a community who is, that are working together to come up with the most reliable knowledge about the natural world that we have. So I just bring this up because I've had this as a question before, whether or not, if this is a theory, does that mean that it's factual or not? This is absolutely factual. It's just that maybe some of the specifics will change in the decades or centuries to come. So the dispersal from Africa, this can also be called the Great Migration, but as someone who studies US history, that term, the Great Migration, is also used to describe the migration of Black and African American folks from the US West going to the US North. So I'm opting for this other term, this dispersal from Africa, which probably led to the first wave of what is now the sixth mass extinction. And this began about 40,000 years ago, with additional waves occurring later, including about 15,000 years ago in the Americas. So this is, we have now reached the sixth mass extinction. We have now reached today's topic. And it only took us 43 minutes to get there. But we're going to talk about humans for the rest of this class. So thank you for going on that journey through time with me. So why this is important, why this likely happened, is that humans have always altered their environments in which they live. So this is starting with the Paleolithic period with hunter-gatherers who were acquired the use of fire. Obviously, as we know, in California, fire can get out of control very easily. They also engaged in horticulture, and they also hunted wild game. The word Paleolithic itself is Stone Age, which refers to the peoples that lived about 2.5 million years to 10,000 years ago, a period that includes around 99% of human history, which in reading that reminds me how truly small we are. Anyway, that existential crisis aside, we are now in the Holocene. Welcome. So all of organized human history, including the first cities and farms, emerged during the current interglacial phase of the Pleistocene, starting around 12,000 years ago. So again, this is known as the Holocene, and this epoch saw human social organization explode with the emergence of new cultures. Our impacts on the environments also increased, and this occurred relatively slowly, or at least incrementally in most areas. So if we're to go back and look at this map, this isn't like a speed contest going from one place to another. It's not like they're just going without stopping. This is slow. It takes time. We're going, we're moving, we're hanging out, we're seeing things. We're surprisingly hunting woolly mammoths because they exist and weren't just featured in the Ice Age movie for nothing. There's also big sloths. Everything's beautiful. We're figuring this out over thousands and thousands and thousands and thousands of years. So these forces have accelerated over the past few centuries, leading some to argue that the Earth entered a new geologic period epoch called the Anthropocene, which is our topic for tomorrow. And this period in this is the period in Earth's history when humans have come to dominate the global geological, ecological, and climatological processes. So we will again talk about this tomorrow and also the rest of this class, and depending on what you study the rest of your lives. But this is a really interesting to me example of thinking about the whole history that we just talked about. We see the geology, we see the animals that maybe died in the Great Dying, maybe they died after, and all of these this cultural baggage, all of this infrastructure, all of this money that is, this concept of just paper money is only, well, paper money is only like 200 years old. Currency in general, maybe 5,000 years old, 6,000. And all of these changes just breaking everything open that are really only a couple hundred or a couple thousand years old if we're including the history of money. So today, one of the, besides watching the documentary on the sixth mass extinction, I wanted you to read a very short piece by Rachel Carson called A Fable for Tomorrow. Rachel Carson is one of my heroes, a really cool lady who got up to a lot of mischief to fight for environmental rights in the US. She's considered the mother of US environmentalism. That's a bit of a misnomer and really a whitening of that. Of course, there have been people who have been really focused on the environment for much longer than the US has been a thing, but I digress. Rachel Carson was extremely impactful in the 20th century, and how the 20th century global West understood the stakes of what people are doing with the environment, of how people are involved in the environment. So in her very short story, which hopefully you did read it, it will help you with your attendance question, but if you did not, please read about tomorrow. So in her short story, she writes of an idyllic US town with a bountiful ecosystem of flora and fauna swaying and chirping until a strange blight, that's what she calls it, leaves sickness and death in its wake. So this leaves the whole area silent as everything is dead or dying. The culprit is a fine white powder that is responsible for the destruction. So in her book, she wants to unmask this grim specter that she calls it, that was brought on by humans, which is DDT. So have a short little documentary about Rachel Carson and DDT that we'll watch, and then we'll do our attendance question.
Pesticides weren't always thought to be harmful. To the contrary. In 1947, Time magazine carried an advertisement claiming DDT was good for people, homes, and farms. It took 20 years before scientists realized how dangerous it was.
It begins with the war-born development of DDT. This diabolical weapon of modern science saved millions of humans, but killed billions of insects. Man, with this newly discovered force, has at long last gained the upper hand in our age-old struggle. Just like these mosquito larvae, it came from laboratories where top scientists from famous universities and from industrial and government organizations collaborated to develop something new and different. They succeeded. They perfected Pestroy, the most effective weapon man has ever wielded against insects. To begin with, this new pest killer is a DDT preparation. We realize what that means. Once a bug comes in contact with DDT, he's lost. All he has to do is just walk on any Pestroid-treated surface. DDT is absorbed through the feet and spreads throughout the insect's entire nervous system. The effect is disastrous. DDT seems to literally drive bugs crazy. But not for long. DDT next paralyzes, then kills. In both its forms, powder and liquid, Pestroy means doomsday to us insects. For this new insect destroyer contains a lot of DDT, Not just a little. Its DDT content is even higher than government specifications. But the really sure kill feature of this insect killer isn't simply that it contains DDT, it's the way that it makes sure that bugs get the DDT that's in it. The same deadly effectiveness of the liquid form is found in the Pestroy powder. It is so easy to apply because of a new efficient dispenser package. All people have to do is to press the patented top like this. It's a handful of concentrated death. This powder is truly activated. It contains stabilized pyrethrum, an ingredient which literally stampedes insects from their hiding places to bring them into contact with DDT, indoors or outdoors. Stirs them up, drives them out of cracks and crevices.
With the possibility of a serious infantile paralysis epidemic, health authorities of the city of San Antonio, Texas, attacked the germ carriers throughout the city. With the war-discovered DDT in special sprayers, sections of the city are blanketed with the insecticide in the fight to stop the spread of the dread poliomyelitis. Every suspected spot is sprayed. Even the streams are disinfected, and in the parks and public places, children are forbidden to gather. Tons of DDT are used in this fight against the dread disease, whose principal target is the young. Again, war has contributed one of its discoveries to save life.
From 1945 to 1955, annual pesticide use on farms went from 125 million pounds to over 600 million. Soon, government agencies began treating even the suburbs with DDT.
People thought it was a good thing because they got action in solving a problem as they conceived it. They were, for example, complaining about mosquitoes. And if the spray truck came down the street, they were told to just stay indoors for a few minutes and everything would be all right. So you had the government endorsing a product and you had the chemical industry pushing it very aggressively.
There was a development program going on within the corporate system saying, well, if a little bit is good, a lot more is much better, isn't it?
Public health departments staged demonstrations to convince the public of DDT's effectiveness and safety. Enthusiasm for the chemical knew no bounds, and few were questioning the wisdom of such use. Public places and private backyards were being treated whether people liked it or not. In 1957, planes sprayed a Massachusetts bird sanctuary owned by Olga Huckins, a friend of Carson's. In fury and desperation, Huckins told her what had happened. The birds showed all the symptoms typical of DDT poisoning. Huckins knew that the planes would be back in spite of her protests. She asked Carson for help. Carson later remembered how the thought of a spring silent of birdsong had moved her to action.
It was your personal letter to me that started it all. In it, you told what had happened and begged me to find someone in Washington who could help. It was in the course of finding that someone that I realized I must write the book.
We have to remember that children born today are exposed to these chemicals from birth, perhaps even before birth. Now, what is going to happen to them in adult life as a result of that exposure? We simply don't know.
This is one of the nation's bestsellers, first printed on September 27, 1962.
In her groundbreaking book, Silent Spring, Rachel Carson jolted a prosperous post-war America, a country confident that science and technology were leading the way to a future in which disease and hunger could be overcome. In no small part, thanks to a new generation of powerful pesticides. But in Silent Spring, Carson warned that progress had a price.
These sprays, dust, and aerosols are now applied almost universally to farms, gardens, forests, and homes. non-selective chemicals that have the power to kill every insect, the good and the bad, to still the song of birds and the leaping of fish in the streams. All this, though the intended target may be only a few weeds or insects.
Through sheer determination, Carson participated in an hour-long CBS News documentary on pesticides.
CBS reports The Silent Spring of Rachel Carson,
which aired not long after Silent Spring became a national bestseller.
Can anyone believe it is possible to lay down such a barrage of poisons on the surface of the earth without making it unfit for all life?
While Carson didn't contend that chemical insecticides must never be used, she faced harsh opposition.
A spokesman for the chemical industry, Dr. Robert White Stevens.
The major claims in Miss Rachel Carson's book, Silent Spring, are gross distortions of the actual facts, completely unsupported by scientific experimental evidence and general practical experience in the field. If man were to faithfully follow the teachings of Miss Carson, we would return to the Dark Ages, and the insects and diseases and vermin would once again inherit the earth.
And when CBS turned to government experts, the questions were many, but the answers few.
Dr. Paige Nicholson, water pollution expert, Public Health Service.
Do you know how long the pesticides persist in the water once they get into it?
Not entirely.
Do you know the extent to which our groundwater may be contaminated right now by pesticides?
We don't know that either, nor do we know if concentration may be occurring in groundwater.
There appears to be growing concern among scientists as to the possibility of dangerous long-range side effects from the widespread use of DDT and other pesticides. Have you considered asking the Department of Agriculture or the Public Health Service to take a closer look at this?
Yes, and I know that they already are. I think particularly, of course, it's Ms. Carson's book, but they are.
Ms. Carson maintains that the balance of nature is a major force in the survival of man, whereas the modern chemist, the modern biologist, the modern scientist believes that man is steadily controlling nature.
Now, to these people, apparently the balance of nature was something that was repealed as soon as man came on the scene. Well, you might just as well assume that you could repeal the law of gravity. The balance of nature is built of a series of interrelationships between living things and between living things and their environment. You can't just step in with some brute force and change one thing without changing with many others. Now, this doesn't mean, of course, that we must never interfere, that we must not attempt to tilt that balance of nature in our favor. But unless we do bring these chemicals under better control, we are certainly headed for disaster.
Rachel Carson, author of the landmark book Silent Spring, started a revolution. During the 1950s, when crop dusting planes and insect sprays blanketed plants with DDT, Carson warned of the dangers of chemical pesticides. She warned of science's power to alter nature and called for government action to protect its citizens. Because of her courage, the disaster did not come to pass, and with Carson's words and spirit, the modern environmental movement was born.
So I have a couple reactions to that, and I'm going to ask you for yours in just a minute, but can I just say that the image shown multiple times of them spraying swimming pools and the barbecue always make me gasp. I have seen this documentary at least 12 times in the past 5 years, and I am always just taken aback by that. And it is always very hard to see the animals suffering in that, especially the bird. Though I should be more sympathetic to bugs. They are so useful. Other things I should point out is that Rachel Carson was a scientist. She was marine biologist, I believe. And I don't hate anyone in this world, but I really do not like the scientist who said just really awful things about her and talked about what modern chemistry and what modern biology believe, because of course Rachel Carson was a modern scientist, and he was the doctor, I believe his name was Dr. White. I think that is a very appropriate name for him. But he was coming from a perspective that many in the global West had in the 1940s. After World War II, there was a great belief in technology and what technology could accomplish, both in the scary, catastrophic experiences that came with the development of nuclear power and nuclear weapons, but also amazing, not only like weaponry but technology that was then adapted to try to make the modern world more modern, and DDT is an example of that. So as one of our last things to do, I want you to use the chat if you are here and answer this question. So how can we see the Anthropocene in A Fable for Tomorrow, which you read hopefully for today, and the Carson's fight against DDT that we just saw in the documentary? So we talked a little bit about the Anthropocene. You may know the Anthropocene from other classes, especially ES3, but the Anthropocene is the current geologic time that we are in. It is the human-centered geologic time. How are humans and all of their messiness, all of their chaos, all of their cultural baggage, how is that seen in A Fable for Tomorrow and or the DDT shown in the documentary? Just a couple sentences in the chat. While you're doing that, I will check the chat to see if there are any new questions. Yeah, so a few of you are talking about even more examples of DDT being dropped. Isaac mentions that they used to strap straight DDT while migrant farm workers were working. Other times the ecosystem saw remediation while the farm workers were left sickly. This is actually something that is still done today. DDT has not stopped. We even though there has been a lot of outrage and we have the different environmental movements, especially kicking off in 1970, DDT is actually still used, and depending on where you are in the world, still dropped on workers and farm workers especially, but other workers in agriculture all over the world deal with tremendously awful management practices, not only from their employers, but also management of the land that impacts their health. So we can totally talk more about that. Richie mentions that there's a Vox video on that. They also forced Mexican immigrants to take baths in DDT. Yes, and sometimes that has happened more recently than you may think. Humans can truly be awful to each other. We can also be full of beauty and grace and love and care, but especially with some of the cultural baggage that we will be talking about as we dig further and further into the Anthropocene, humans are we have a great potential for cruelty, but we also have a great potential for love. Okay, Richie provided the link for the documentary if you want to grab that. And now I am seeing some answers. Beautiful. I'm going to read the names out as I see them, just so you know that I got it. We have Chloe, we have Jasmine, we have Hunter, we have Wilbur, we have Ellie, Dylan, Madeline, Isaac, Andrew, Kylie, Anne, Caitlin, Carmenita, Anna, Carissa, Ian, Sophia, Kiana, I hope I'm saying your name correctly, Stephen, Natalie. I'm just doing that out loud because I have had some students worry that I wasn't getting their response. And a couple more that just came in. So Natalie, Harry, Stacy, Matthew, Hayden, Daniel, Charlene, Emmeline, Jade, Hannah, Catherine, Camille, Yenny, and keep them coming. I'm just gonna quickly, got one from April. For next time, we're going to dig more into the Anthropocene. So before class, I want you to read what is the Anthropocene and why does it matter. And then I have a podcast from one of my most favorite podcasts called The Anthropocene Reviewed, and it's by John Green, who reviews air conditioning and sycamore trees. It is not a straight history or a straight review of air conditioning and sycamore trees as you might think, or just by hearing that it's a review of something. It is much more than that. And as we talked about today with the history of the world, somehow in less than an hour, history is messy, which has led to an even messier Anthropocene. And the rest of this class is going to be focused on getting into some of that messiness. Let's see. Let me see. So I have Yenny, April, Jacqueline, Araceli, Natalie, Jose, Susie, Shania or Shania. I hope I am pronouncing your name correctly, but I'm sorry if not. I got a direct question. Is there a way you could make an Excel sheet for us to check our attendance? No, but if I can let you know if you have any questions. Richie and Connor. So keep them coming. Thank you, Samantha and Michael. I am going to stop sharing right now. Does anybody have any questions for me before that might be helpful for other people before I let you go? I'm still recording right now. But if you have a question about something to do with class, speak now or forever hold your question. All right, I'm going to stop recording.